Hi there, 8th grade, volume of pyramids and cones for lesson 86. Students will understand the relationship between a pyramid and a prism with the same base and height. Students will understand the relationship between a cone and a cylinder with the same base and height. Students will use the formula for volume of a pyramid and the volume of a cone to solve geometry and word problems. Students will be able to compare the volume of a similar solids. Power Up is on the top of page 575. Alright, here's some of your formulas. Formula volume of a cylinder is pi r squared times height. Think of find the base and that whole area. We are going to then take times the height to find it. Volume of a prism is length times width times height. Nothing extreme there. Volume of a cone is probably the only thing that's a little more difficult. The thing about a volume of a cone, think of the fact that if you actually finished your cone and made it circles on both ends, it is a cylinder. So, it is just 1/3 of pi r squared times height, which is the exact same formula, but the height will be, or it's just, you only take 1/3 of it. Alright, Aiden built 2 cones out of sand on the beach. The diameter of the smaller cone is 6 inches and the height is 5 inches. The diameter of the large cone is 12 inches and the height is 10 inches. How many cubic inches of sand did Aiden use for each cone? How many times greater is the volume of the larger cone than the volume of the smaller one? Alright, so you are building this sandcastle, okay? And it is a cone. So you can draw a picture. You have to. I don't know how good mine's gonna be. Okay, there's my cone. This one has a diameter of 6 inches. And it is 5 inches. Okay, now we have to find the radius, which is 3 squared times pi times height, which is, then it's a cone, so we got to take 1/3 of it. That would have been the formula for the cylinder. We times it by 1/3. So we're going to get 9 over 1/3 times pi times h. H in this case is 5. So I'm going to take this and multiply it, end up with 3 pi times 5, which is actually 15 pi, which 3.14 times that is 47.1. And that would be inches cubed. Alright, now over here, we have the big cone. I don't usually do it this way. Actually, that might look better anyway. Alright, so now we have this cone. The diameter is 12 and the height is 10. Okay, we're going to take the radius, which is 6 squared times pi times height, which is 10. Don't forget this is a cone, so instead of just doing the cylinder formula, we do the 1/3. So we're going to get 36 here. 36 times 1/3 is going to be 12. going to give me 10 times 12 is going to give me 120 times pi. 120 times pi. It's going to give me 376 point. Well, really, if I round it at any rate, I'm going to be at this point. Okay? So let's take 3. So there's my volume of both of them. Now I need to know how many times greater the big cone is than the large or small cone. So divide 377 by 47.1. And it is about 8 times larger. Which kind of makes sense. Okay? Because of the fact that you doubled your height and you doubled your radius. So you're looking at that's just 4 right there, and realistically when you square things you're probably looking at doing it again, so I would say that's pretty accurate. Alright, the volume of a pyramid, and I didn't put this on there? Oh, how dare I. Alright, the area of a square pyramid is going to be like a rectangular prism. The only thing about it is going to be 1/3 of that. So, what I mean by this is basically we're doing the exact same thing we are of a cone, only they start usually with the cylinder and then do 1/3. Here we are going to look at what a rectangular prism is, which if you remember was volume equals length times width times height. Okay, width would have been 90, or height, or length and width would have been 90 and 90, and height would be 50. Now this ain't a rectangular prism. This is a square pyramid. We are going to do the same thing we did with the cone. We're just going to multiply it by 1/3. 8100 times 50 and 1/3. We're getting big enough I can't probably do this one in my head completely. Good time probably to pull out your calculators, just see all your steps. I'm going to try to get that number smaller by dividing by 3 or multiplying by 1/3. Get that back down to 2700. Isn't much better, but it's still better. And then I'm going to take that times 50, and I should get 13 or 135,000 centimeters cubed. Okay, it's the exact same thing. You just got to remember what it would look like if it was all the way, if your lines could extend straight up. Well, it would look like a rectangular prism. Alright, in this case it'd actually be a square. Or no, it wouldn't. It would be a rectangular prism because the height isn't the same. So then you just, alright, now I need 1/3 of it because it's a pyramid. That's the only difference. Alright, a pyramid is shown, the area of its base is 36 pi. Its height is 10 units. Well, the base, if you remember from the last problem, was just length times width. So we are just going to take this base. It's already given me the base. Thank you. Awesome. That's one less calculation I have to do. And I have to multiply that together. Now, the worst part about this with the square root in there makes life a little bit harder. So I'm going to do the square root of 3 in my calculator, which gets me about a 1.735 or 32. Then I'm going to times that by 36, which is going to give me a 62 point this times 10, which will give me 623.5 units cubed. There's your practice set. There's your homework.